All right, Stacey, here we go. We have a dilemma del dia that's focused on multiple slit thinking. And I was going to say before you watch the screencast, please have done the following two things. Make sure that you've watched the previous screencast on the lecture on multiple opening interference patterns. And also, if you would, do this problem yourself before looking at the screencast as best you can, figure out what's going on. And then look at the screencast to make sure your understanding is as clear as possible for yourself. Thanks. So let's take a look at what this problem is. This is an IB question, and it looks like they have a graph that looks like you have the overall primary interference patterns shown nicely here. You have this single slit envelope that's occurred here. It's nice. There's these secondary minimums. It looks like there's two of them. So that would tell us that there's four openings that are making this interference pattern. And if there were more and more slits open, we would expect these secondary bumps to disappear and these to get bigger and thinner as it gets brighter and brighter. The angle here is in radians going this direction, and then they have this weird spacing where it looks like they have 10 boxes. Yeah, 10 boxes to get over to 0.5 radians. So each box is 0.05 radians when you're thinking about the pattern that you would use. And just to be clear about it, so the single slit pattern, which is dies off here, so the theta for that, where we use B, would be from here over to here, and then the theta for using D and using the D sine theta equation would be from here over to here, because these little guys disappear as you get more and more openings. Anyway, here we go. Explain why the intensity of the light is 16 I0. And sure enough, here's 5, 10, 15. It's right at 16. I divided by I0. I0 is the intensity of the light at the middle of the screen for one slit, the single slit intensity. But we've opened 4 identical slits. So that means 4 times as much amplitude. So since we're going to have 4 times as much amplitude, 4 squared, since intensity is related to the amplitude squared, that's why we're expecting to see 16 there. Yeah, I think that's about it. You might mention constructive interference. They're mentioning a theta equals 0, so you might say something about all the path lengths being the same, something like that, or that they're all in phase, some kind of statement about that. The width of each slit is 1 micrometer, 10 to the negative 6 meters. Use the graph to estimate the wavelength of the light. Well, each slit, that's B. They just give us B. So when they give you B, you're looking at the single slit envelope. And so this is what you want. And this is annoying because it's 0.5. So this is 0.4, because it's right. You got to go 2 boxes to get to 0.4. Looks like it's to the right of 0.4 a little bit. I don't know, 0.4. It's not 0.45. It's not 0.4. So 0.42, 0.43, something like that. They must give us a little bit of a range in the mark scheme. Use the graph to determine an estimate for the wavelength of light. Well, we can just say theta equals lambda over B and do a quick little simple math there to get the wavelength. And it looks like that's what they did, and they got 430 nanometers here. So that works out nicely. They did accept a range, and then they just didn't give you any points if you use D. If you use the topic 4 stuff about the double slit equation instead. They did allow you to do this, which is interesting as long as you made it a B, but don't be doing this equation at all, or they take lots of points off. So it's very important, again, that we keep clear the difference between the single slit envelope and then these primary interference peaks that are D sine theta, right? Equals n lambda. Awesome. Okay, C, the arrangement is modified so the number of slips becomes very large, not just 4, but more, and their separation widths stay the same. State the 2 changes in the graph as a result of these modifications. So these primary interference spikes are going to get bigger, bigger, and bigger, and the width of them is going to get thinner. You're going to get brighter and more distinct. I guess we could just say that they're going to be thinner and brighter. They also stay at the same place, which is an interesting idea, and so that might be in mark scheme as well. Let's take a look. Primary maximum become brighter, more intense. Primary maximum become narrower or sharper. And then I didn't talk about the secondary maximums become less important. They disappear. So that I would have lost a point there because I didn't talk about these little secondary bumps here. So the more slits you get, the more of them there'll be. This will always be n-2, so this is 4 openings, which is why we have 2 bumps. So if we had 8 openings, we'd have 6 little bumps, and they would get smaller and smaller and smaller, which is why when we get to a diffraction grading, they're not here at all. We just have these main spikes. So there we go. And I hope that helps you understand this question and how multiple slit patterns work out. Good luck and hope to see you soon.